Okay, so this is 5.1 to 5.4. We're dealing with Lewis structures. So Lewis structures are a way to understand what shape compounds will take, and it starts with understanding how the bonding goes. So I am doing something different than the book. It is, in my opinion, easier to get the right answer than what the book gives you. So I hope that you'll give it a try and that you'll find out it's not so bad. So here we go. Okay, so let's do an ionic Lewis dot structure. And what do I mean by ionic? This is an ionic compound. So the first thing you're going to do is count the valence electrons on each atom. You will then arrange the atoms as a dot structure on each atom, or arrange the electrons as a dot structure on each atom. Write the arrow indicating the direction the electrons will go, cation to anion, and finally rewrite the compound using the ions as ions using square brackets to indicate charge. So you put a square bracket, and then in the top right corner you indicate the charge on the element. So let's try sodium chloride. Sodium is an alkali metal, so it's a +1, or sorry, it has 1 valence electron. It's going to end up being +1. And chlorine has 7 valence electrons. So we go ahead and we put those around. All right, and then we know that we're going to take the electron from the sodium and give it to the chlorine, because chlorine is much more electronegative than sodium is. We do that. And then we rewrite things. So I've got sodium in square brackets with a positive, like a plus sign on the top right. I've got chlorine with square brackets with negative sign on the top right. And then I'm going to add those electrons in. And that is the Lewis structure for sodium chloride. Let's try another one. Okay, so let's do calcium chloride. There are 7 valence electrons on chlorines. There's 2 of them, plus the 2 that you would get from calcium gives you a total of 16 valence electrons. So we put calcium in the center and add the valence electrons on each atom. Okay. We're going to draw arrows to indicate that we're going from cation to anion, and we're going to take 1 electron for each chlorine, so that we end up with 8 around the chlorine. Then we're going to rewrite things with square brackets, and we're done. So that wasn't too bad. So when you have more than 1 electron kind of fill the octet, that's usually what happens, and you want to balance it out as much as possible. The most electronegative thing is going to end up with the negative charge. All right. And that brings us to Lewis structures of covalent compounds. So these rules are basically completely different from what the book tells you to do, but they are more comprehensive and they will work more of the time. So try to follow these. Number 1, determine the number of valence electrons. Universal thing when you're doing Lewis structures. Number 2, arrange the symbols of the elements in a pattern that shows how their atoms are bonded together. Put the single bonds between central and outer atoms, and that is a single pair of electrons. So you take the metal, you put it in the center. The thing that's less electronegative is going to be in the center. That is the cation, or it would be the cation if it were an ionic compound. It's not quite for a covalent. Anyway, you put it in the center, and then everything else goes around the outside. And this will take some practice to do correctly, but we'll start there. You then complete the octets of the atoms bonded to the central by adding lone pairs of electrons. And this is an important caveat. Hydrogen only gets 2. It does not have an octet. Why does it not have an octet? Because it only has an s orbital, and s orbitals can only have 2 electrons. Okay, then number 4, we will match the number of valence electrons in the Lewis structure to the number determined in step 1. So if you got to the right number by filling out the outer atom, cool, we've got the right number of electrons. If not, you have to start adding electrons to the central atom. So 5, complete the octet on the central atom. If you cannot complete the octet on the central atom, you need to convert a lone pair from one of the other atoms into a double bond. And if you still don't have enough, then you go and convert another one and form a triple bond. So let's do an example. All right, so let's give it a try. Carbon monoxide has 4 valence electrons on carbon, 6 on oxygen for a total of 10. All right, so we've counted our valence electrons. We're going to arrange the symbols of the elements in the pattern that shows how their atoms are bonded together. So in this case, we just have C going to O, and we're going to put a single bond between carbon and oxygen, and then we'll complete the octets on the bonded on the atoms bonded to the central electron. In this case, we don't really know what the central is, so we'll just put them around the oxygen because it's more electronegative. And if we have a hydrogen, it doesn't have an octet because you can only have 2 electrons. It's only got an s orbital. So finally, we match the number of valence electrons in the Lewis structure to the number determined in step 1. In this case, we get this structure. Now, I have represented here all of the electrons, and I haven't put a line for the bond. And this is so that I can remind you that each bond has 2 electrons. There should be a line there, but there's not. When we count this, we do not have an octet, so we go to number 5. We need to complete the octet for both the carbon and the oxygen. Oxygen currently has one, carbon does not. So we're going to pull electrons, and we're going to put them into bonds. And in this case, we will need to do that twice. All right, so we do that. And I have the representation with all of the electrons, and I have it with lines here. We have a triple bond for carbon monoxide. I am doing this because I want to point out that when you have 3 lines, that represents 6 carbons. So when you go to count your valence electrons in the Lewis structure, you have 2 unpaired and then 4, 6, 8 bonded. Sorry, 2 paired, 4, 6, 8 bonded. Don't forget that each bond has 2 electrons, or you will get these things wrong. All right, so to summarize, for ionic compounds, count the valence electrons on each atom, arrange the electrons as a dot structure on each atom, write arrows indicating the direction the electrons will go, cation to anion, rewrite the compound as ions using square brackets to indicate charge, and FYI, if you have a covalent compound with the charge, you do the square bracket thing as well. For covalent compounds, determine the number of valence electrons, arrange the symbols of the elements in a pattern that shows how their atoms are bonded together. You put single bonds between the central and outer atoms. That'll be a single pair of electrons. You'll complete the octets of the atoms bonded to the central atom by adding lone pairs of electrons. But if you have hydrogen, it doesn't have an octet because you only have an s orbital. It can have 2. Match the number of valence electrons in the Lewis structure to the number from step 1. And if you don't already have one, complete the octet on the central atom. If you can't complete the octet, then you'll need to convert a lone pair from one of the atoms into a double bond. If you still don't have enough, you do a triple bond.